Hi everyone, this is Aykut from System Craftsman. Today I'm gonna present you a video that I recorded almost a year ago for Red Hat webinars. It's called Functionia, an event-driven adventure in the serverless metaverse with OpenShift Serverless. So I hope you will enjoy it, and don't forget to like the video and subscribe to my channel. Hello everyone, my name is Aykut Bulgu. I'm a senior content architect at Red Hat Global Learning Services, also served many years as a consultant at Red Hat. Today I will guide you through this webinar, which is based on the upcoming OpenShift Serverless course that will be available in a few months. Today we are gonna learn about traditional long-running applications and their drawbacks, creating functions for OpenShift Serverless, OpenShift Serverless serving and eventing, and building blocks for eventing like source, channel, subscription, broker, triggers, and more. In our story, Functionia is a serverless metaverse where there are many clans for any purpose. There is a core clan which consists of a group of decision takers for all Functionia clans. Also, there are other clans like bitminer clans that do mining on particular set of bitmines. The core clan invites you to Functionia to solve a few problems of theirs. You wear your VR headset to log into Functionia. In your journey, the avatar robot OCVR4 will help you through. OCVR4 is fully uploaded with the OpenShift Serverless knowledge. So this is the core clan on the left. They say that miner clans do bit mining in a daily basis. Sometimes no bit mining is done, so no economical bit mining architecture. There is no economical bit mining architecture. This means resources are used for nothing sometimes. Code bases of miner clan apps are too complex, so this creates a hard development lifecycle. There are also more than one technology like Quarkus or Node.js, so it makes maintenance hard with complex and polyglot applications that the clans have. So OCVR4 jumps in and says he has a solution, OpenShift Serverless. With OpenShift Serverless, you can deploy and run serverless containers and use any programming language or runtime. It's powered by a rich ecosystem of event sources. OpenShift Serverless is based on the project Knative, and you can manage serverless apps natively in Kubernetes and run anywhere that OpenShift runs. OpenShift Serverless provides basically serverless functionalities on hybrid clouds. It provides a simplified developer experience, immutable revisions, a polyglot language set to be chosen like Java, Python, Go, JavaScript, and Quarkus, and Spring Boot and Node.js, of course. Automatic scaling, it provides automatic scaling, and in the core of it, there is event-driven architecture. You can deploy OpenShift Serverless as an operator and manage its lifecycle via Operator Hub on OpenShift. Core clan members ask how it is supposed to help them. OCVR4 might have an answer for that. So OpenShift Serverless has two main pillars, serving and eventing. Serving is an event-driven model that serves the container with your application and can scale to zero. It has advanced networking that provides traffic splitting and immutable revisioning mechanism. Knative services are the core objects of the serving. If you want to use serving, you have to create a service with or without a function. We will come to that. Eventing is the common infrastructure for consuming and producing events that will stimulate Knative service applications. It has objects like source, channel, subscription, broker, and trigger. There are types of sources and channels like ping source or in-memory channel, which is the default. But in Functionia, you will use a Kafka source and a Kafka channel. So we will be using Kafka. Reducing complexity is the key to a serverless adoption. OpenShift Serverless reduces complexity with less resources to create an application. It even has a CLI that provides no YAML usage for the developers, so it makes development very easy. We also have functions in OpenShift Serverless. As a part of the serving, functions make it really easy to create a single action application logic that is ephemeral. This can be considered as the next step in the application architecture evolution in the cloud. So let's roll up our sleeves and start the implementation. The first implementation is for creating a Knative source and sink. We will use a Kafka source to get bitmine data from Kafka, and we will create a sink as a serverless function for the Quarkus clan. So this is our project. We have a Kafka cluster here consists of one broker and one zookeeper. This is based on AMQ streams, and we have a bitmine courier here that will produce some bitmines into Kafka to a specific topic that's configurable with an environment variable. And once we create our functions here, first we will create our Quarkus mining service function. And once we create our Kafka source, that will be fed by that bitmine messages. So let's first create our Quarkus function. We are in the, I'm actually in this repository in here. This is actually a folder. We have a bunch of resources here. Let me close this one. We have a bunch of resources here for each scenario. We will be creating our applications, our functions actually in here. So let me first create this function. We have a command called kn function. This is the knative command, and with knative command you can use function to create a function. This L stands for its type. This can be any technology that is supported, like Node.js, Python. This T is the event type. We now are creating a function that uses a cloud event, and this is the name of the service. So this will create a project, function project for us. We will open that in our IDE. So let's create our function here. So we have our project in here, and it's a Quarkus project, and it has a POM XML, and it has there's a test in here. It has a function in here, and as you can see, it uses the cloud event from the Knative events, cloud events class. So we will do a few changes in here. Let's do that. Let's first add a model in here called bitmine. This is a class and this is a model class. We will get rid of this one, please, actually. And in bitmine, I will copy and paste this. This is actually a bitmine object which has type, weight, and status. And let's do the changes in the function too. So in the function, let's first change method signature should be like that. This is the input. And for the output, let's do something like this. And let's return, let's do a system out println in the end. So we don't return anything in this case, but we are printing it. You can say, what's the catch in here? We will do a small thing here, like setting the status as processed. We don't need this import. And let's change the test2 to because it fails right now. Let me just overwrite all of it, which will be better for us. I did this before, so this will surely work. Otherwise, if it doesn't work, it will fail in the function build phase. So it's important for us to make the tests run. For the sake of time, I did it before, so I just copy it and paste it. It just checks the object and the cloud event. So our function takes the bitmine output, sets it as processed, and prints the cloud events. So let's build and deploy this function. Let's build and deploy it. For that, in the applications folder, let's do kmfunc deploy. You cannot actually deploy before building, so I'm using deploy with build in this case. So let's set our registry. If you are doing this for the first time, you build the image. It requests you to write an image which will be deployed. It can either be an internal registry or external image registry. For our case, that should be, let me check my notes, QA.io and my organization name, and that's all. So if you have something like QA.io, your organization, / Quarkus mining service, it means that you can deploy your image in there. I will show it to you. Actually, I have that configuration. I set it up before too. So let's skip this. It says building function image. So let me copy my username in there. For this, I have a robot account. So this is my username. And this is my token for that. So it starts pushing the image into the registry. it's now in my local environment. It's already built like this, and that will be pushed. Yeah, it's deployed in here in our selected namespace or project, whatever. It's Functionia, as you can see. It's already in the service name too, and it's built here. As you can see, it says a minute ago. So going back to our topology in here, we can see our Knative function. As you can see, it's just a Knative service, but it's built as a function. So for now, it's one pod, and yeah, as you can see, it's auto scaling to 0 because there are no traffics going in. So that's a great feature, I think, because this is what Core Clan asks, to be honest. Yeah, it's auto scaled to 0. So as you can see, it's now it doesn't work. There is no pod for that. Let's go back to our example. Now it's time for us to create the Kafka source, because we need a source. We have the sink in here. We have the sink. This is the sink. We have Kafka. We have the Kafka producer. We need something here to be a source for us. So let's go back to our resources, and here I prepare the Kafka source for Quarkers. Check out that its kind is Kafka source, to be created in the namespace Functionia. We have a bunch of labels in here. Be careful about this Bootstrap service, because this is the Bootstrap server address. This is actually the one of the service address that AMQ Streams exposes. And the topic, for the topic, it's bitmine. And we have the consumer group name, that can be anything. And we have the sink. This part is important because this has to be defined particularly for that service. So in our case, the KN services name, KN service list, yeah. As you can see, we have the Quarkers mining service. It's the service name. So we can call this Quarkers mining service, and this is the API endpoint. So let's go back and change this, apply this actually. So OC apply -f resources, oops. Oh, we are in the Quarkers mining service, sorry. OC apply -f resources, and the first one, the Quarkers Kafka source YAML, to be applied in Functionia project. So let's go back. As you can see, the Kafka source is created in here, and it's bound to our Quarkers mining service. So one thing to do here, it's okay, but we should create the topic, the Kafka topic. If you don't create it, Streamz will automatically create it for you. So remember that the topic's name should be actually bitmines. Let's create that one. KFK, this is the Streamz CLI command. Streamz CLI is open source, so I'm using that for direct operational things on AMQ streams or streams. So KFK, K, topics, great. Yeah, let's say that should have 8 partitions and replication factor 1. And the topic's name is bitmines, as you can see here. So let's run this one. Okay, probably that's because we have the consumer. No worries. We already have the bitmines topic, so that's great. Next thing is to set the concurrency target. Let's check out our KN service, and as you can see, it has the first revision. Now we should update our KN service to only accept one concurrent request. We have to do this for, oops, sorry. We have to do this for our demo. Let's say in the scenario, the clans only can handle one concurrent request. So we are setting the concurrency target to 1. So let's run this. This will update our service, by the way. Yeah, as you can see, it's updated to the second one here. And when we do a KN service list, it shows us the second version. So let's create a few requests here. To create requests, we are using a bitmine curious root endpoint, and I will create 10 requests in there, and I will use a command called stern to check out the logs from here. So let's wait for it to, okay, it's auto scaled down, so let's send 10 requests in here. Let's check out all of the bot logs from here, and let's see what happens in here in the UI. So as you can see, it's scaled up to 2 pods already. So for 10 messages, it scaled up to 2 pods. If we used 20 or 50 messages or something, that should be higher. So it's automatically scaled up to 2 pods for our case. And you can see the messages in here. It should say something like processed. So you can see that they show the status processed here. And if we go back and check out our application, you can see that it processed all of the messages and auto-scaled to 0. Core Clan and Quarkers are very happy with the change. Quarkers can process mines very efficiently. But what if more clans join? They seem to have another clan that also do mining. What if they join too? OCVR4 has an idea for that. What about using a channel and subscriptions for this? In OpenShift Serverless, you can create a channel and subscribers for that channel. Creating a channel for Kafka is possible in OpenShift Serverless, like we said before. In Functionia, we can create a Kafka channel that sends bitmines to its particular topic, and each clan can subscribe to it with the help of a Knative subscription. So for the second part, we have to get rid of this Kafka source. So let's delete this Kafka source first. Then we have to create the noders function. So let's go to our command line interface, and in the Functionia directory, let's create our noders mining service with this command. It's the same command actually, but with a few changes. First, that should be a node function, again with the cloud events, and its name is different. So let's create this, and it created the noders mining service in here. Like the Quarkus one, it has a function YAML. This time it doesn't have a class or something, of course. Let's close this one too. But just an index.js. So we will do similar changes in here in this one. I will get rid of these actually. We should have a event data status processed in here. This event actually stands for the cloud event object. The same with the Java one. Under that we have a data, which stands for our bitmine particularly, and we are changing its status in here. So we should do a console log in here too, like we did for the Quarkus one, and we are logging the cloud event by JSON stringifying it. So that's all. So let's go back to our command line and cd into noders. The same command here, can func deploy build. Yeah, again the same. We will use the same registry, QA.io, and my personal organization name. It will build it like QA.io system craftsman / noders mining service latest. The same mechanism runs. I'm using the robot account, like I said. So this is the username and pass. Yeah, it's now pushing. Yeah. So let's see our function in here. That should be somewhere in here. Yeah, this is the noders function. Another mining service function actually. So let's do the same for this one too. This service as well takes only one concurrent request, gets only one concurrent request. Yeah, that should update the kn service list, update the services. As you can see, both of them are updated to the second one. So this shows that any revision is immutable, and there is a revisioning mechanism actually in OpenShift Serverless. Let's go back to our code example. We have to do the second step. We have to create a channel. Now we have to create a channel, and we have to create two subscriptions. Okay, so let's check out all these and apply it all in one time. We are creating a Kafka channel, and that Kafka channel should define a partition and replication factor. This defines the partition number and replication factor of the topic it creates. So it specifically will be creating a topic in Kafka, and we will tell our bitmine courier to use that one. So after that, we have to create two subscriptions, one for the Quarkers. We will tell Quarkers that use this channel with the name Kafka channel. We have the Kafka channel name in here. Use this name with the Kafka channel, and as a subscriber to the channel, I want you to use this service. For this one, this is the Quarkers mining service. For this one, this is the Noders mining service, and for the same channel. So let's go back to our command line and apply all this. -f resources. The second step, I'm applying it all, by the way. And I already created two of these subscriptions. No worries. So let's come back in here and see what happens, because yeah, it created, as you can see, a Kafka channel in here, and we have our subscribers. For this Kafka channel to be used, you have to, in the let me show it to you. In the Knative eventing, project, you have to create this Knative Kafka. And in this Knative Kafka, you have to define, you have to enable actually, you have to enable the broker. We will be using this. You have to enable the channel. That's why we can use that channel. And in that channel, we have the Bootstrap server definition. It's like the Kafka source, but it's something subscribable at once. So you define the channel in here with the broker. Actually, this is the skeleton. This is like the configuration of that channel. And when you create the Kafka channel, that will use this configuration. Same for the broker. And yeah, we have the source enabled, so we already used that. So let's go back to our Functionia. This is the administrator view, by the way. Let's create some traffic, right? Again, with the same curl, let's say that 20 maybe this time. Let's stop this guy. Let's create 20 this time. Let's check out Node.js ones. Oh, this doesn't work because we didn't change the topic name. It's now targeting to bitmines. Now we are reading from another topic. KFK topics lists. As you can see, we have the bitmines and we have a topic like this one. So we should change our topic to this. Let's change that topic name in the bitmine for the bitmine courier. Let's roll out our deployment config. That will be rolled out in a minute. Okay, I'm checking that, by the way. That's fine. So let's do the curl again and run the stern. This time we have something, right? Yeah, you can see the processed bitmines here. And look at the numbers. We have 3 pods in here and 3 pods in here. That's great. Quarkers and noders are now very happy that they can do mining simultaneously. But wait a moment, they realize that they have the wrongly processed mines. Quarkers has the mines of noders and noders has the processed mines of quarkers. OCVR4 says that he can help. It suggests using a broker and triggers. The brokers and triggers are similar to channel subscription mechanism, except that they support filtering of events. Event filtering is a method that allows the subscribers to show an interest on certain set of messages that flows into the broker. In this case, the bitmine event types are either noders or quarkers. So we can do the filtering with the cloud events type attribute. Yeah, we had the logs before for the noders mining service, but we didn't notice wrong type of events in here. No, wrong type of bitmines actually in here. This is the noders mining service, but this says type quarkers. Let's first get rid of those channels and other stuff. So actually, let's go back to our latest command and delete everything in here. So that will get rid of the channel and subscriptions. Now we will create a broker and 2 triggers. In order to do that, we have to use the resources in here. We have a Kafka broker in here. Remember that we had a configuration for that broker. So this configuration comes from that Knative Kafka resource. And if you change this config map manually, the operator, the OpenShift Serverless operator, will override it with this configuration here. Okay, so let's go back to Functionia, and let's create these guys. Before that, the same mechanism actually. We are creating a broker, and this broker uses the Kafka broker config. This means that will create a that will use that broker configuration, and behind it will create a Kafka channel for us. So, and in the triggers, and we have to define triggers, and let's check one by one. This is the quarkers trigger, and we have the subscriber mechanism again. It's the subscriber, and the reference is the quarkers mining service. The important difference here is it has a filter. Since the object, the carried object is the event, it has a type attribute. And we say that type should be quarkers for quarkers mining service. The same for the noders. For noders mining service, that specific type should be noders. So let's go to our command line and let's apply this. This time that should be the third. I'm applying all, by the way. I won't be doing it one by one. So yeah, I have the triggers before. That should be created for you. And let's go back to our topology view. You can see our Kafka broker here, like the channel before. And we have the services in here. So like the Kafka channel, this guy should create a topic for itself with a different name. Let's go and check it. Let's list all topics, and yeah, it's here. So This was the channel one, and this is for the broker one. So let's tell our Bitmine courier about this topic. This is the topic, and let's roll out this Bitmine courier. And once it's rolled out, we can send some messages again. This time maybe a few more, like 50. Yeah, it's updated. So let's send 50 messages to courier this time. And let's run Stern for noders again. So let's wait. Yeah, we are having the messages, and the pods are beginning to scale up. This one is to 7, and this one is to probably 8 or something. Oh, it is 7 too. So yeah, we have our bitmines generated in here. So you can see these all are noders right now. So the labels are fixed, and now each miner clan processes their own mines. Happy with the latest changes, Core Clan says there's a new small request that came from another clan, Wakanda, the actual source of one of the bitmines, which is Vibranium. The Core Clan wants the Noders clan to only process 80% of the Vibranium and send the rest to Wakanda. As always, OZVR 4 knows the solution. Let's do some traffic distribution on OpenShift Serverless. So let's check out our services first. Okay, service lists. You can see the current services. Let's update our another service with the knative tag. This command can service updates the noders mining service with the ones tagged as noders mining service, the second version as noders. So let's run this and let's check out can revision list. As you can see, we have the second version tagged as noders, and as you can see, we have 100% traffic for this one, and for Quarkus it's the same, but we just tagged the noders. So let's go to our code, because we will update our function. In the function, we have to change the processed message, because for some we shouldn't process them, but we have to send them to Wakanda. So we have to change the event data status. So let's say if we have something like this, that should send to Wakanda, right? Else that should set its status to processed. If the data type is Vibranium, that should be sent to Wakanda. Let's build this. See the noders. Let's build our can function deploy builds. It will ask for the QA IO username and password again. Yes. username, password. Since there is no traffic right now, yeah. So let's check again revisions lists, and as you can see, we have the third one, and there is no traffic because it's just being deployed. After some time, yeah, this gets the 100% traffic. So now we have to change it. We have to tell the service that it should, we have to first tag this new one to just take this the third version as Wakanda. So let's check out the revisions again. As you can see, it's Wakanda and others. So with these tags, we will update these revisions to get the traffic. Noders should get 80% and Wakanda should get 20%. And let's see what happened in here. Yeah, as you can see, we have 80% for Noders and 20% for Wakanda, and this is the updated one. So any Vibranium will go to here. Let's check out our topology view. As you can see, in our topology view, this is the third version and this is the second version, and it shows very well that this should take the 80% and this should take the 20%. So this actually stands for the canary deployment. Okay, let's create some traffic. Let's send some bit mines to our services. I sent 50 bit mines, and let's check our services. Yeah, they are scaling up 6 2, so maybe we won't hit that log, but let's do our best. Let's go to our command line for the Noders mining service. Let's do a stern. Oh yeah, we have it. We have the third one, as you can see. Let's search for Vibranium in here. Yeah, for the third one, it's sent to Wakanda, as you can see. And let's see if we have, for a second version. As you can see, it's the it says it's processed, so it works. So you and OCVR4 made all the clan happy with efficient and easy work. That's all for this presentation. Thanks for listening and thank you for joining this webinar. You can find all the resources in this repository, including the code and the resources that are used. Thank you very much, and please don't hesitate to ask any questions if you have.